everybody for coming to my talk today. I know you have many choices and you chose to come here, so thank you very much. And my talk, by the way, Enter the Brave New World of GenAI with Vector Search, is more for beginners. So if you are already working with deeper into GenAI, you may find it a little basic, yeah. But then, as such, I'm kind of running into a lot of developers who are experienced, but just not having worked with GenAI yet. So I kind of hope to have this more of introductory GenAI, but also for experienced folks like yourselves. Yeah. So my name is Mary GRYGLESKI. I'm a developer advocate, and but currently I'm actually transitioning between two jobs. So I will become a GenAI practice lead in a few weeks, and for a consulting firm based in Ohio in the US. And I'm originally from Chicago. So that's about me very quickly, but let me do that. And my clicker is not working, so I have to kind of go back to my keyboard. Okay, so this is the agenda for today. I'll have a quick introduction, also a brief background of AI, and then understanding the players of this GenAI era. And then introducing to you the terms that are more popular, like GPTs, NLP, LLMs, and then getting into a bit of RAG, and also vector database and vector search. And then kind of, if I have time, I'll do a very quick demo as well, and then discuss some of the benefits and challenges. But first of all, may I ask you, how many of you are already working with generative AI apps? So quite a few. Are you already using some libraries? Maybe are you Java developers, or are you, yeah, so LangChain 4J, maybe? Yeah, okay, some of you maybe like Python, maybe? Yeah, and maybe, right? Yeah, LangChain, I suppose, yeah. Anyway, I just thought I kind of get a feel, so then I know how deep I should go for some things. And I just don't want to offend you if you already know something. So let me know if it becomes, too easy or too hard or something. Feel free to ask me too. I prefer interactive kind of way too. And all the terms, okay, so let me go to the next page. First of all, very quickly, I already mentioned I'm a developer advocate, and I'm also Java champion, and I run the Chicago Java users group as well in Chicago, in US, and so that's me. But prior to this, last year I came and had the good fortune of speaking here. I was speaking about Apache Pulsar, if you were here. Back then I was working for DataStax, a company that's US-based, and they are back then it was streaming, but then they got rid of the streaming, and now all Gen AI, and then not only that, it's gonna do all JavaScript. So that's why I said, not really, I mean, I can work with JavaScript, but not completely JavaScript. But anyway, so I'm switching right now. So, okay, so that's about me, some streaming distributed systems and all these things that I'm truly more interested in, the deeper things. But as such, I switched to Gen AI. Actually, I'm kind of liking it because if you are familiar with vector database, vector search, which I'll kind of touch upon a bit, is that it touch upon, linear algebra. So kind of the math that's behind it, that's fascinating me because I was a math and computer science major when I was in college or university, and I never got to use it for many years. All of these calculus, linear algebra, all these things, finally get a job that I can actually apply that knowledge to understanding like things. So that's something I'll go over in a little while. So let me kind of first start giving everybody a brief background of AI. Just very briefly too, if you kind of look into AI, it's actually, it's just throughout history there's already been folks that wanting to do things that are essentially about, automating things, that making human beings less having had to worry about stuff is really about automation. But you may be saying that, yeah, computing is for automation, but artificial intelligence aims at making the machines even think. So that's kind of a fascinating kind of thought about it. So if we kind of look back like 100 years ago in the 20th century, if we kind of pinpoint about this wave of AI, right? It started in like about the 30s, golden age of science fiction. Alan Turing, which actually I had a kind of a very honored. Last year I spoke at the Manchester Jug and then walked by the statue of Alan Turing. That was real nice. And so can machines think? And that's when he started to kind of asking explicitly this question. And then, as we all know, right, the last century, it was kind of all these research that are being done. And by the way, I didn't create this chart, but I got it from this link. So I'll be sharing the slides too if you're interested. So if you can kind of take a look at it, all of the research are being done, and of course there were world wars and a lot of advanced technology being kind of done, and then getting into the artificial intelligence deep blue. I actually worked for IBM too for a few years, and so as an advocate too. So that kind of fascinated me too. Deep Blue, 1997, and it was developed just to play chess at that time, and it defeats Gary Kasparov at that time, in chess, as we all know. So yeah, so that's kind of, let's lay the stage, but nothing about ChatGPT then. So okay, wait, let me see. I don't know how it gets into here. I think because I clicked on the wrong link. Yeah. Okay, here we go. So AI. So it's really about AI is all about automation, but just a step up than just pure traditional computing. We're trying to get the machine to think. So if we kind of quickly, let's kind of get this understanding, set the stage. So AI is, think of it like an onion too. If you keep peeling, okay, so the outer layer is basically artificial intelligence. It mimics the intelligence and behavior of human beings or any other living entities, but it's more vague. But when you kind of get deeper, then that's basically applying machine learning techniques. As such, it's basically a computer can learn from the data itself. There's actually, ideally, right, there's no need for us to even train the computer to think. It's basically you give it data, and based on the data, it will learn on its own. That's machine learning. But just alone, like machine learning, is not enough. And then as such, we get deeper into deep learning. That's what it is. And it kind of involves neural networking that basically kind of mimics our nervous system, how we think. And that's where all the research these days are being done. And that is all the ChatGPT, LLMs, all of these are in this particular core of this onion kind of a layer of kind of concept. So let's kind of take a look then at this fascinating look at the GenAI era. As such, right, it came out in November of 2022, so kind of a year and a half ago, and it took the world by storm. About a billion download within 5 days, and people were all like wowing. And it certainly was impressive because it can write an essay, you can tell it to write code, and all of these things. So it's kind of interesting. So let's just understand it, generative AI. So there's also predictive AI too. And if it's like predictive, that's already been going before generative AI. But as such, generative AI is disruptive, and it has potential to change the way how we create content and consume content as well. The difference is that between predictive and generative is that generative tends to be dealing with data that's less having a time constraint to it. Like if you think of it like predictive AI, we tend to be using it for doing business forecasts, weather forecasts. There's a time element to it. So things would expire. If you kind of send it some data and say, okay, giving me some, weather forecast within the next month. So after a month is gone, then the data, whatever you get from it, won't apply anymore. Whereas for generative AI, we're talking about writing an essays, designing a fashion, and writing code. Even now, right? Gemini, or actually OpenAI, came out with Sora. That actually it can generate videos too. Is pretty impressive. So there's no time element to it. It tends to be dealing with more of the creative side of human activities too. So if you can kind of think of it that way. And GenAI makes use of both machine learning and deep learning kind of techniques to produce the contents. So it's a bit of history too, how this all started, right? We look at that earlier chart of where AI generally kind of started. But for GPT, there was actually about 20 years ago, like 2003, there was a first feed-forward neural network language model designed by Joshua Bengio in 2003. And then not too long after that, Apple then brings AI and NLP, natural language processing assistant, to the masses by releasing its first Siri, iPhone with Siri. So that's already another form of AI kind of assistant. And in 2013, there was also a group of Google researchers developed Word2Vec. And that's kind of important in terms of, the today's ChatGPT kind of evolution, is that it actually forms the basis of how the current vector database is based on. It's basically you are using a neural network to learn like word associations too. So that's kind of the techniques that's being used from there to kind of being used and then applied to today's most of the vector database. That's how it works. And then in 2017, if you have been following too, then there was this paper called like a new network architecture called the transformer by Google. And if you have heard of the phrase, they said attention is all you need, and that's where it comes from this particular research like paper too. So that's that. Okay, so that was a bit of history. So let's kind of also take a look at the players in this new Gen AI era, right? So we talk about generative AI, then there's a model side of things. So we all know OpenAI is like the de facto organization that's kind of governs a lot of these models and everything. But OpenAI is not the only one. But of course, the most famous now is GPT 3.5 that came out in November of 2022. And then of course GPT 4 came out like last year too, not too long after 3.5. And as such too, if you kind of look into it, right, there are also capability of generating text to images like Midjourney, DALL-E, and also essentially stable diffusion too. That came out of Stability AI. That also is kind of another kind of a branch of this, Gen AI era, more dealing with images. And then there are also Whisper from also OpenAI that deals with more audio type of kind of generation. And then Codex too is that model is for that. And that's what GitHub. Copilot kind of is based on the Codex. And then, of course, there's Llama 2 and then Llama from Meta, or the formerly Facebook. And then there's also an earlier form I didn't point out is BERT from Google, too. So, and of course, there are more like models coming out. In fact, I don't think I even mentioned, but maybe in the next slide. It's basically talking about the apps then that kind of makes use of these models. So as you can see, all of these are more apps that makes use of all of these models. And I was going to say to Bard, Gemini came out of Google quite recently, and its multimodal kind of capability is actually quite powerful. And I haven't used that, but from what I heard, it's actually quite powerful too. So if you want to kind of be able to do text to images, text to audio, all of these is actually quite comprehensive in that sense. And then, all of these are generative AI like apps, and Bing AI, Salesforce, SEO, and basically this is just a small handful of examples too. So there are the model side and then the apps that makes use of these models. So just wanted to kind of point out too, I think it's kind of becoming more important these days is basically the modality of Gen AI. And again, when it first came out, it was more text to text. You're kind of prompting it using text and it gives you back text. But the thing is making it more useful is being able to do multimodal thing. You give it text and it comes back with images or code, or the other way around, showing a video, be able to identify what's on the video and then generate some words to describe the video like that. So that's kind of like an expanding area. As we can see, Gemini already came out with this capability too. So that's kind of a growing kind of area of research in this space. And how about then people, right? There are people players too. And I think earlier, especially too, there were people worrying about things such as ourselves. We are more developers. I'm assuming most of you are developers here. So you're like, okay, it's going to take my job. Honestly speaking, I really don't think so. And I want to tell you a story too, real quickly. I flew, so before I came to the US, I spoke in India for this conference. And then from India, I flew to Hong Kong, where my sister lives. That was like 2 weeks ago. And so after that, I flew here, but then I was on Zurich, in Zurich, Swiss Air, and then they canceled the flight to London City Airport. So I said, oops, and then what to do? And they sent me an email. I mean, there was nobody call you, and then just says, okay, you've been rebooked on British Airways and to Heathrow. I said, okay, good. But I still want to call someone, and plus my suitcase was nowhere to be found. So I kind of tried to search, and there was no phone number. So there was only one link, and the link is about a chat assistant. I'm guessing it must be using ChatGPT, but there's nowhere near. And basically, I was like chatting, okay, while waiting in line, all these things. And I said, please, where's my suitcase? And it gave me back a lot of the very routine kind of, boilerplate kind of answer. Oh, you kind of got to file a report, do these things. And I'm like, no, at that point in time, I just arrived in Heathrow, my bag wasn't with me. So I wanted my bag. So I said, please, connect me with a human. And then basically it came back and says, I do not understand your question. And then I kept saying that, please connect me with a human, give me a human voice. And it says, I must be not capable. I cannot help you with this. I'm like, what good does it do, for a chat GPT? It's trying to kind of help me. It's not even not helping me, but making me more kind of frustrated. But anyway, I was just kind of saying that I don't think is truly, this ChatGPT is able to do much yet. I mean, it fascinates us for writing essays and all that, but I think it's still got some ways to go, being able to actually think. To me, I think if you have to prompt it, it's not really AI. That means you have to know what you're looking for to ask it. It should be, I just don't quite know what I want, and I give it some text, and you kind of figure it out for me. But I think that level is maybe still quite lacking, is my experience. But anyway, I was just gonna, let me go back. I was talking about the people player. So kind of coming back, I think, developers, we still have, plenty of opportunities. And for one thing, we have to check and make sure that GenAI generates the right thing. And there's like a lot of work to kind of verify. So I think just don't worry about it. And I don't see people worrying about it now, which is good, because we realize it's not quite ready. Anyway, so just wanted to kind of talk about this too, the people in here. So for us, right, we're developers. And these days too, I think the developers would be more, say, we describe developers or engineers more about as us as data engineers or AI engineers that are kind of focused on implementing techniques to implement the AI, the chatbot. And as well as also on the ops side, like DevOps people will probably be doing more machine learning ops too, which actually that area to me is still growing because it's still not very clear what needs to be done. And as such, if you have been following and doing machine learning, you know that there's the machine training phase. That's when you generate your model. And that's kind of a lot of work too. You need to be able to supposedly constantly update the model, but it's actually very expensive to do that. So anyway, that's that. And then there's also this RAG techniques, and which I'll talk in a little bit, which is a design pattern implementation, up to you how to do it, to kind of fill in the gaps that LLMs can't do it, all of these things. And there's a lot of operation stuff involved too. So I think there's a lot of growth in there too. And then there's also like data scientists too, and they are the ones that are subject matter expert. They know what it should be. Usually too, as developers, we are more about how do we do something, but we need to know what needs to be done. So that would be the data scientists, the computer vision engineers. So these are kind of, I look at it more like the players in this space. Okay, so now let me make sure. Okay, so let me get into the next kind of terminologies about generative pre-trained transformer, GPT. So what it is, right? So essentially too, it takes simple prompts, right? The prompts, that's the difference now, is that it's no longer required that we do it like the old-fashioned computer way. There's no need to kind of say, okay, I need to do something and then dash parameters, dash flag, you pass the parameters, very restricted. These days, we can just talk to the bots like you talk to another person. So that's another kind of a, how can I say, like very advanced type of way of doing things now. Talk to it like a person as input, giving it. And then it's, as such too, the GPT then would take the input and essentially do pattern matching and then go and find the results that you want to look for, right? These are similarity searches that are being done. And then it answers questions for the prompts too. And then the results is that it will produce content such as a new essay, a blog post, designing a dress. And we already see the fascinating things that ChatGPT can be doing too. Okay, so real quick too. Then there's also this GPT kind of technology. So really quick history is that it started showing up at around like 2018. There was Alec Radford's paper on GPT generative pre-training of a language model. So that came out at OpenAI's website, and is basically, showing how a generative language model can acquire knowledge and process all of the dependencies too, based on pre-training on a large and diverse set of data. So that's kind of the start of it. So roughly 6 years ago, and then OpenAI releases, soon after that was GPT-2. So that includes the data set expanded more to include like 9 mission documents, all of these things too. So it's a little bit, we can see too, the revolution has started. It's become, all of the research organization, they're doing more and more of this research. And as I mentioned earlier too, Stability AI in 2022 developed like Stable Diffusion. So that's a deep learning text to image model too that generates images based on text prompts. So that was also innovative. And Dolly came out because of that, and Midjourney was all affected by, kind of like impacted by it and started to come out. And then, of course, 2022, ChatGPT came out that releases GPT 3.5. So it's an AI tool that reached like 1 million users within just 5 days. Yeah, as we know, that's becoming history now. All of these kind of in 2023, 2024, this ChatGPT revolution continues too. And there are, big companies like Microsoft, Google, all of these releases their own AI and all of these things that are coming out. I guess Microsoft has Bing, and then Google has BART, and BART is kind of more evolutionary from their BERT model too. And then, and as such too, as we're speaking, there are just new models that came out. And as I mentioned, like OpenAI has the Sora that came out that could do video too. So that's pretty innovative. So let me then look into the next terminology is NLP, is natural language processing. So that's very center to this Gen AI kind of revolution because, well, NLP by itself is an interdisciplinary subfield of linguistics of computer science. So it's basically, its purpose is to process natural language data sets too. So it takes all of these huge data sets they call corpora in the machine learning term, and speech corpora, and process them too. And it uses like rule-based or probabilistic machine learning kind of approaches too. And it basically enables computer to learn from the contents, right? Including, and not just like based on the contents, it will actually produce results that's more than just what you're looking for. It's basically giving you a context, and that's what is kind of wowing people is this kind of level of capability in NLP too. And essentially too, it allows you to draw insights from the documents too. And let me kind of go to the next one, which is large language models, LLMs. As we all know, as developers, then that's the models that we work with every day. And this is like a type of machine learning model, and it's foundational type of model, and it takes a lot of times, especially if they are general knowledge ones that came out, right? GPT 3.5, the ChatGPT 4.0, all of these too. It needs a lot of pre-training, and it takes like weeks, if not months, and then tons of processors like GPUs, all of these. So as we can see, it's not like for common people like us to do it, all of these generic model. However, there's also company that, for example, like, LLMs are usually general purpose, but then there are, a lot of knowledge too. Let's say I'm in an insurance company or a law firm, I have specific data that are private. So you can also develop your own private LLMs too, and kind of do pre-training on those as well. But those are in general, it gives you more control and over it too. Otherwise, if you're using publicly available ones, we know that it can be a bit kind of dangerous in that case. So essentially, large language models is what we interact with, and it generates and classifies text and performs the NLP, the natural language processing task behind the scenes. And it answers questions, answers all of these prompts just like a human beings, and then analyze also the sentiments too, and chatbot conversations. All of these are really work of LLMs. So if we kind of look back into the earlier onion picture, if I have to describe LLM, where it sits is basically inside the deep learning kind of layer, and is specifically the Gen AI kind of section. And you can see LLMs are transformers, and the image gen, for example, is like with the GAN and the VEI kind of techniques too in there. And then this is just how it's kind of, if you kind of look into the whole picture, sometimes I like to look at overview rather than just doing something without knowing. So just thought I'd share this. And this came from Google Cloud that described it quite well. So I thought I'd share this. Okay, so now then question is, how can I work with LLMs? And I already just now mentioned some of you, a few of you already working with LLMs, Gen AI apps, and you know that LangChain seems to be the most popular right now. It's primarily Python, also has JavaScript and TypeScript to it. And then there's also another one is quite popular. It's called Llama Index as well. And then also too from Microsoft, they have the open source semantic kernel that also has a Java SDK to it too. But otherwise too, it's also Python. A lot of these LLMs, as we all know, because of machine learning, most of them are Python. And then Java is, I think it's kind of slowly catching up, I should say. And then there's also from Google, there's Palm that actually interacts mostly with its Vertex AI too. And then there's also one thing I want to point out. For example, you want to work with models, you can also go to Hugging Face if you are not already familiar with it. So think of Hugging Face like a repository for AI type of models. And you can find all of these models that are being uploaded by different people in there. There's just tons of it there too. But it also kind of reminds you too, it does it is quite big, I should say. So yeah, it's not like you just have to make sure you have enough space to store whatever you're going to be downloading. So. But think of Hugging Face. I think there are comparisons saying that Hugging Face is like GitHub, storing all of our source code in a repo, but Hugging Face is like storing all of the AI models for us. So, okay, so now then let's say, and DevOps is traditionally more Java, so I have to kind of honor to the Java side of things. I feel that actually Java has a lot of potential in it because Java is still going strong despite a lot of naysayers saying that it's going to go away. I don't think so because there are already a lot of installed applications all around the world. These are server-side enterprise kind of large systems, right? So as such, I see, Java having a really good potential, and there are already libraries developed, such as I think here too in the conference. I think Liz she works with LangChain 4j if you've been to her session, and so LangChain 4j is a very common one for Java, and then there's also semantic kernel that has Java SDK, and this one too. I just want to point out too is from Jake J Llama, if you're interested too, and it's these are all open source, by the way. So that's basically JLlama is a Java implementation of the Llama 2 at this point. I haven't checked lately. I worked for DataStax before, so Jake is like the architect of at DataStax. So he did that. And then there's also another library. It's more low level. It's also by DataStax, the tech co-founder. It's called JVector. And that one, if you're working with, especially if you're a Java person, you want to work with some of the lower level vector API. And he developed this currently is used by the DataStax database called Astra database. That's based in Apache Cassandra, by the way, is the vector implementation. So he applies JVector, and it kind of speeds up all the like vector search kind of techniques in there. So, and that's that. And then also one more is Llama 2 is a direct port from Llama C. So just kind of give you some information on that. Okay, so now let me kind of quickly show too is that Hello World in LangChain 4j, how is it being done? So this is kind of simplified and it's real quickly, but if anything, all things when we learn first is always a Hello World. So how would you do it? So as you can see over here too, when you work with OpenAI, if you haven't already done so, you want to make sure you get an OpenAI API key to it too. It is true, it's not free as we know, but the ChatGPT 3.5 is more affordable. I should kind of remind you that. Otherwise, if you use ChatGPT 4, that's actually more expensive, as some of you already know. So you just want to make sure you get an OpenAI API key first. And in this case too, you just need to basically set up your language model, and then in that case, then you can just quickly do a model and .generate and hello world, and then you print it out, and that's what it is. And of course, this one isn't really going too far. It's just simple hello world. So this is how you can do it in using LangChain 4j really quickly. Okay, so another thing I wanted to get into too is kind of really quickly, because you might have also heard of RAG, and it's retrieval augmented generation. So why is it needed, right? So essentially, too, if you kind of look into LLMs, and LLMs are static, kind of contain data that, let's say, right, GPT 3.5, actually, it was released in 2022, but the data that it it actually got pre-trained on is only up to like 2021. So then like what happened now, right? If you're using ChatGPT 3.5 and then there's new data, so it is not able to find those information. So there's a techniques being developed called RAG and retrieval augmented generation. It's essentially a hybrid framework that will integrate two components of this RAG model. So as such, it is an architectural pattern. It's not how it implements. And how you implement it is really up to the developer, or sometimes there are vendors that also coming out with RAG kind of capability too. But essentially too, the concept is that you have two models. One within it is retrieval model and generative model too. So as such, the reason for this is that you want to produce text, that's not only like contextually accurate, but also information rich. And information rich is essentially being done by the generative model side. So really kind of quickly kind of describe it in a nutshell, right? Retrieval model, think of it as like a librarian too. And it pulling in all of the relevant information from a database or any kind of external data source or any kind of corpus of documents too. And as such, what it does is that it retrieve. I mean, its role is to do retrieval. So it gets the information and it will feed the information over to the generative model. So generative model too, if we kind of take a look into it, think of it as like a creative writers. And so it takes the information from, synthesizing all of the information from the retrieval side, and then it's essentially put it into more coherent and contextually relevant kind of text. And then it's built upon LLMs too. So it's basically, whatever gets kind of retrieved, it will actually think of it like beautifying it and making it information rich, right? That's the one that's working with LLMs, be able to produce the results that's kind of contextually rich in there. So that's what it is. So kind of over here, as described too, is that generative models on this RAG is basically serve as final piece of the puzzle, right? It essentially what gets generated, right? What we see, let's say in a ChatGPT app, it gives you the contextually rich kind of output that we interact with. So that's RAG really in a nutshell. So now then, let me kind of also make sure not running out of time. Vector database and vector search. So let me get into this base. So as you can see, right, LLMs, you can query all of these things, but it actually doesn't, it's a very static piece of humongous data. It doesn't know how to keep any information. So it doesn't have any state to it. So that's one drawback of LLMs, as we know. And the thing is too, is that a lot of times though, when we get into doing real life situation, we don't just ask and then walk away. A lot of times we ask, but we want to keep a context, for example. So those things, you need to kind of think of ways, how do you store the data? So you can obviously do in memory. You can also see to a lot of database or even OpenAI, it has in-memory embedding model. But the thing is too, we would suggest is to use a database, just like these days, traditional applications, we're using relational database, for example, but vector database is essentially purpose-built. It's really for serving up vector data type, right, for complex machine learning purposes. So that's another thing too. You might also have heard of embeddings if you haven't already. So what is embeddings, right? So if you kind of think of it, well, how does vector database work? So essentially, too, if you look into a typical kind of vector database, that means you are supporting data type that can do multidimensional data support. So how does it do multidimensional? So think of all of the data you come in. There's a string that comes in. You need to embed it first. So the embedding is essentially you translate it into some numerical representation. And the representation is essentially an array of floating point numbers to it. So then like each string comes in, it can be translated differently. And you do need to rely on some embedding model to do it too. So when you do query and when you do storing, you want to make sure that you're using the same model. Otherwise, you won't get the same answers. You want to use the same model essentially for both storing the data and querying it and retrieving data from it too. So I hope that makes sense. So essentially, if you go into a database and then you do a select that particular vector data column, it will come back just all the numbers too, and they are floating point numbers. It's just not human readable too. However, why is it necessary? Is because it's very complex, right? We're talking about you want the data being able to kind of reflect on complex kind kind of subject matter that captures like the dimension, the context and everything. So you require like a complex way of doing things. Now, if you are a math person, you are aware of there's scalar data type, which is just single dimension, and there are multi-dimensional data. So that relies on, if you're a math person, then you know there's linear algebra that deals with vector data type, right? Vector data type, think of it not just the magnitude of this data, but there's a direction that's associated with this data. So let me kind of go over there. Oh, let me kind of go back in here. So this might kind of makes a bit more sense rather than just me talking. So embedding model, right? It transformed the text into a vector, call an embedding. So you can kind of draw it out and look at it like two-dimensional. And so if you kind of look into it, this data is being represented as V1 and V2 and V3. So based on this, then we want to do searches, right? So you can say, okay, I'm going to come in, I have some data, V1, V2, and of course in real life there are many vectors scattered on this two-dimensional space. But my vector 3 is this query kind of string coming in. So I want to see who is closest to me. V3, I'm trying to search for it. And obviously in this case, V2 would be closest, right? But of course in real life, there could be many too. But of course, that's only a simplified way of describing it. But to kind of try to understand this vector database initially, you can think of it like this, like two-dimensional. All these data is represented in this space, and you want to look for the closest point to what I'm looking for. So that's what it is. Now, that's kind of simplified. This is kind of an example too. Is you can say, right, it could be a word of a cat, and then a dog, and then a house. You're looking for a house, but actually somehow in this particular case, the dog would be closer to the house. But maybe dog is a little bit more loyal and stays in the house or something, right? So anyway, so that's just kind of like quickly describing to you what is vector embedding and then being used in vector database search. So in kind of a pictorial fashion. Now, if you want to kind of get into a bit more detail, this I won't get into all of it, is that there are also supposedly different layers too that actually goes into searching. Now, this actually will involve a lot more math. That's kind of trying to calculate. You're looking for some information that will go through and searching for all of these things. And that's all the algorithms of linear algebra that's working to kind of search for your answers. So as such too, there are techniques, and it's called approximate. You might have also heard of it, approximate nearest neighbor. And then there's also, I forgot exactly, KNN too. There are different kind of nearest neighbor algorithms that are being done. And these are, again, more like math kind of models that kind of would be searching for you what you're looking for in the database too. So here too, it just kind of to summarize, I know I talk about vector database in 5 minutes, and so basically, right, nearest neighbor embeddings, all of these, and also wanted to point out too, there's also an HNSW too that's also being used. For example, Elasticsearch, that company, they were using more HNSW, and that's a little bit, oh, I forgot exactly. Somehow when I'm at conference, I forgot. You know, if I'm talking with someone, I kind of remember. But anyway, HNSW is a bit of an older techniques, not too old, but the thing is too is that it's not as efficient as more of the ANN, the approximate nearest neighbor kind of searches too. So essentially, vectors are new type of data supported in a lot of established databases. So I just want to kind of go back. Actually, I have this wrong. But just examples of a couple of vector databases. If you're looking want to work with it, open source, I just want to share just the open source one. For example, like there's Milvus and from Zillis, this company Milvus, and also PG Vector. If it's Postgres, if you're a Postgres user, there's also an extension of it that supports vector database, and that's called PG Vector. Although I do have to point out they don't use ANN, they use KNN, so it's slightly different in that case. And then there's also Chroma and FAST. FAST is from Meta or Facebook, and they also have it's also like open source database, and also Quadrant too is another popular one. And there are millions of other ones too, but I just want to point out these seem to be the ones that are quite popular for open source. Okay, so that's that. And then, okay, so just really quickly too, what are vector embeddings being used for, right? So as such, right, I kind of quickly go over vector search, vector database, and essentially search, right? And it's basically, you want to be able to find, looking for results in your set of data. And then you want to rank it too. And not only that, and a lot of times too, in also like doing searches, you also wanted to say how close is the percentage of the results I want to get, for example. So doing searches is first and foremost for vector embeddings. And then there are also like clustering recommendations, especially if you're doing like a shopping cart kind of example or doing shopping, if there are recommendations too, then you can also use these techniques to do recommendation. Anomaly detection, diversity measurement, classification. So these are kind of examples of what you can use vector embeddings for. Okay, so just kind of also a quick note to point out too. Now, what about like relational, the database that we're more kind of familiar with? You can obviously still use traditional database to do kind of specific AI type of searches, but it's really not recommended because as such, traditional database deals with only scalar kind of data type, right? And vector database is purposely built to handle multidimensional vector data type. So then traditional database, you will have to use more essentially computing instruction set, right, to kind of search for things. So in general, you don't want to use it. However, in some cases, if you're in a complex ChatGPT applications, you may still want to use traditional database for some things too. So it's not saying that you can't, but maybe just make sure you understand what you're trying to do and then use the right tool for the right job. So that's what it is. Okay, so this too is another diagram to kind of quickly show you too. I talk about RAG and then vector database. And so how does it, if you put it together? So this would be an example of, if you kind of conceptually look into it, there's LLM chain and you using database as kind of the centerpiece to store your embeddings and then doing queries and all of these things too. And then this is kind of represent like a RAG type of AI apps to it too. So yeah, so you can have like prompts coming in and then they get translated, store them embeddings. And then when you go for searches, you'll be searching. Just now I was showing you all of the vector database searches. It will be doing it over there. So anyway, so that's just an example. Let me kind of make sure. Okay, so I only have not too much time, but let me, before I get to benefits, I'll quickly show you then. Over here, there's an example. You can see okay, right? So this actually came out of also like a RAG, just wanted to quickly show you too. This one, I happened to be in India and then was working on this. And as an example, it's called naive RAG. And I mean, this is kind of like in the LangChain 4J terminology. Naive RAG is basically you don't do any, in real life, if you're kind of doing RAG, then you need to process the data, massage it, split it, all of these things. But in a very simple case, it's basically take the data and then quickly do a search like that. So in other words, it's not much to it, just kind of very basic, right? Or naive RAG like that. So over here too, if you kind of, actually, you know what? Let me kind of look into easy RAG. Actually, that's the one I'm talking about. Okay, so easy RAG too is basically you can also like do a load as such, right? RAG is you're trying to load data to augment your LLM. So over here, this is again very simple. And it's basically you do a load document, you load it from some a text file, right? External text file, and then you basically then do an AI services and essentially to like associate with a open AI chat model. And then also in this particular case is we're talking about chat memory, and you should remember at least like 10 latest messages. And then you can actually have access to like documents. You can do then a create content retriever for the retriever too, like that. So in this particular case, it's just a very simple one. It just takes it. So let me kind of run it again, and we can kind of just look into it to run. Yeah, this one is already stop and rerun. Okay. Yeah, so I'm already using JDK22 to do it. But again, this is just very simple. This, again, is not like a UI interactive. It's just command line. So I can just say, who are you? Like that. Yeah, so here too. Okay, now it comes back. The assistant said, I'm an AI assistant providing information about Rising Wave. Like I said, I was working with Rising Wave, and it just kind of like, it's basically you are feeding in some external information to it too, and then it's able to then find it and retrieve data for you, not just like from the LLMs. So LLMs doesn't have any specific data. So in this particular case too, what I do is I do a load documents and load it into my search space, so to speak, and then that also then works with the model underneath the scene. So okay, so I think, yeah, I don't have as much time now. So, but that's, again, it's just a real quick example, not like, too much. But let me kind of go back to here and talk about some benefits before I end, right? Benefits, right, of ChatGPT. I kind of like to say that, ChatGPT, the nice thing about it is kind of think of it like you can just ask it, because through prompts, and then you will receive, right, your answers. But make sure to ask wisely, because these days, right, the ChatGPT is not smart enough yet. So you want to make sure you ask the right things, right? So we all know the benefits. It's kind of wowing us. But there are lots of challenges too. But be aware of these issues, right? These are partial listing hallucinations, as we all know. If it doesn't have the answer, it will give you back wrong things too. I also have to say, earlier I mentioned about the J Llama, that one, and I was using a GPT-2 model to ask for some things about a singer, and instead of giving me answers, it was actually cursing me and said, "I don't know this. Why are you asking me?" Like that. It was kind of funny with using an old GPT-2 model. It's interesting, but I think with the newer models, they are a little better now. At least they say, "Well, I don't know the answers," rather than cursing you or giving you something that's not right. So anyway, so that's just hallucinations. But then there's also ethical concerns too, and can be potential misuse that you need to be aware of. And right now, I think the governments of all the world are still trying to figure out a way of how to regulate the use of ChatGPT, right? And then also, another thing is with the RAG. That's why we're using RAG pattern, because LLMs, generic ones, don't have all the answers, and so you need to make sure that whatever you're looking for, you need to like kind of feed it in. So LLMs are not all magic, in other words. So those are things we're aware of, and resources. Let me kind of make sure. Yeah, I'm about time. So if you're interested in my slide deck, this is how you can access it, and there's also Bitly code or the QR code to it too. Yeah. Okay. 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 If you missed too, don't worry, because I'm very reachable. So I'll be sharing with you my LinkedIn and Twitter, all these things too. But also too, I've been trying to resume my stream, because I used to be doing streaming during COVID times, but now with travel, I'm less. But otherwise too, you can also find me on Twitch, and I also multi-stream to YouTube as well. So that's my Twitch and YouTube channel. And then I want to, oh, this is wrong. Yeah, I don't know why. Okay, ignore that. But anyway, so this is how you can reach me, my LinkedIn profile and my Twitter or X handle, and as well as I have a Discord server too. So if you want to stay in touch with me, you can always find me. And Discord is easy. If you use Discord, we can also have conversations and maybe have a voice, or, we're not in the same place, so we can do a voice or video chat too. And there are other folks in the community as well. So yeah, so with that, I want to thank you very much. I think I'm within time. So thank you very much for coming to my talk, and feel free to stay in touch. Yeah, thank you. Yeah, thank you.